Okay, this is the P3 paper from January 2021. It's question number 8, and if you have a read through of it, you can see that this question is exponentials and logs. It's the work to do with logs and non-linear data. So if we look at it and read it through, it tells me that P is equal to AB to the T. P is the percentage of a population, T is time and its number of years after 2005. And then it says a graph's been plotted of log 10p against T. So that gives me a bit of a clue as to what I'm going to be doing to solve this one. It says once that's been done, we know the gradient is equal to this, and we know that the intercept is equal to that one there. So what I need to do to make a start of this, hopefully you've done a few of these already, they follow a similar sort of format, is if I've got P equals AB to the T, I want to transform this into a linear function, and the way that I'm going to do that is to take logs, and we can see here they've sort of decided for me it's log to the base 10 that I'm going to be doing. Okay, so we log both sides, log 10 AB to the T, and then what we're going to do, this side we're going to transform it using our log rules. So the left hand side doesn't change, but the right hand side becomes log 10a plus log 10bt. Remember, log a plus log b is equal to log ab. We're doing that in reverse in effect. And now the other log rule that we're going to use, I'm going to write it out, is we can take that power down, can't we? So if we do that now as well, we're going to get log 10p equals log 10a plus t lots of log 10b. And now looking at this, this is in the format y equals mx plus c. In fact, let's just slightly change it round. All I'm going to do is move it about a bit, and I'm going to put log 10b multiplied by t plus log 10a. So all I've done is to swap those over, and in addition to that I've just moved this t to the other side of that. Why have I done that? Because now this can be equated to y equals mx plus c. This is going to be the gradient, and this is going to be the intercept if you plot what they've done, if you plot log 10 against log 10p against t here. So what that means is that I can now say log 10b is equal to the gradient, which they said was 0.09, and I can say log 10a is equal to the intercept, 0.68. If you go back and do some of the past papers on these, you'll find that you actually had to read these off of a graph, but more recently now they're looking at just setting them up like this one. Once we've got to this situation, then this is using another of those log rules. I'll just quickly write it out, that if we have log AB is equal to C there, we can rearrange that into a power statement, which is that A to the power of C will equal B. Those two should be interchangeable with each other, going from the log statement to the power, or from the power to the log statement. But if we do that, then what that's going to give me on the left hand side is B equals 10 to the power of 0.09, whatever that works out to be, and on the right hand side A is equal to 10 to the power of 0.68, and then whatever that works out to be. Did they ask us anything about decimal places? Yeah, 2 decimal places. So in other words, B is going to be 1.23 and A is going to be 4.79. Okay, so that's part A completed. Part B, yeah, these are tricky little things. These it'll help you after I've explained this one to you. You just need to go through and do as many of this type of questions as possible, because then it gives you some idea about how to do these. In the context of the model, give the practical interpretation of the constant A. What's A going to be? Well, it's only because I've done these before that what I'm going to do is say P equals AB to the T, and then I'm actually going to, I already know this, I'm going to set T equals naught, i.e. the initial population. If T is equal to naught, it'll be the initial population, but P will equal AB to the naught, but then B to the naught is just 1. So P equals A. So that means A is the initial population. Is the initial population. That's one of those questions that you need to have seen. Some of you will get it, some of you brighter ones, but I wouldn't have got that unless I had it explained to me by somebody in 2005. Remember the actual question here. In 2005. So now that you've seen it, you'll say, okay, I'll be able to get that next time if that sort of question emerges. So that's part B. Only on 1 marker, so it gives you a bit of a clue that it's something clever or pretty straightforward when we're doing it. Then part C says, use the model. Right, yeah, we've got A, we've got B now, haven't we? Use the model to estimate the percentage of the population who had access at the internet at the start of 2015. So the only thing to be careful of is that when we're looking at it, if it's the start of 2015, what's T going to be? Remember, we're starting how many years from 2005? Okay, so let's just do that one. Not really much explanation for the examiner even needed here. We've got P equals AB to the T, but we've got P equals 4.79 times 1.23 to the T. Those two values from part A there. And we're saying when T equals 10, so P is going to be 4.79 times 1.23 to the power of 10. Work out what that works out to be. You might be a bit concerned about the fact of how accurate we've made those ones as we've been going through, but it then sorts that out for us by saying you only want it to two significant figures. Is it 2 significant figures or nearest whole? Oh no, okay, it doesn't say anything. I've just decided to do that then, that by doing that, that makes sense as an accuracy issue with our answer. So for part C, P equals 38. Hopefully that all makes sense.